Welcome back to our AI and data learning series. In today's video, we will continue our discussion on data and explore some very important concepts used in modern AI systems and business analytics. We will discuss data ingestion batch and real-time ingestion, data storage destinations, data transformation, data lineage, data quality (ETL), and ELT data labeling techniques. Let's begin. Data ingestion is the process of collecting, importing, and processing raw data from different sources into a system for storage or analysis. It is one of the most important steps in the data lifecycle because without proper data ingestion, organizations cannot use data effectively. Data can come from many different sources such as databases, sensors, APIs, websites, social media, cloud applications, and business systems. The collected data is then moved into storage systems where it can later be analyzed. There are four major stages of data ingestion. The first stage is collection. In this stage, raw data is gathered from different sources. The second stage is transport. Here, the collected data is transferred to a storage location or processing system. The third stage is processing. The data may be cleaned, validated, or transformed to make it suitable for analysis. The fourth stage is storage. Finally, the processed data is stored in repositories or databases for future use. Now let us discuss data ingestion patterns. The first type is batch ingestion. In batch ingestion, data is collected and processed at scheduled intervals such as every hour, every day, or every week. For example, a company may process all sales transactions at the end of the day. Batch ingestion is suitable when real-time data is not necessary. It is reliable and cost-effective for handling large amounts of data. The second type is real-time ingestion. In this method, data is collected and processed immediately as it is generated. This allows organizations to get instant insights and quick responses. Real-time ingestion is commonly used in banking systems, online shopping platforms, stock markets, and IoT devices. For example, fraud detection systems in banks rely heavily on real-time data processing. After ingestion, data needs to be stored somewhere. This location is called the destination of ingested data. One common destination is a data lake. A data lake stores massive amounts of structured and unstructured data in raw format. Platforms like Amazon S3 and Azure Data Lake are popular examples. Another destination is cloud storage. Cloud providers such as Amazon Web Services, Google Cloud, and Microsoft Azure provide scalable storage solutions for businesses. Data can also be stored in data warehouses. These are centralized systems designed for reporting, analytics, and business intelligence. Examples include Snowflake, BigQuery, and Redshift. Traditional relational databases are also used depending on the structure and complexity of the data. Now let us move to data transformation. Data transformation means converting raw data into a more useful and organized format. This process may include cleaning, filtering, enriching, validating, or restructuring the data. The purpose of data transformation is to make data meaningful and suitable for business analysis and machine learning applications. One important concept related to transformation is data lineage. Data lineage refers to tracking the journey of data from its origin to its final destination. It records how data moves through systems and how it is transformed at different stages. Data lineage improves transparency, governance, compliance, and data quality. It also helps organizations identify errors and understand where the data came from. During the 2008 financial crisis, many organizations faced serious problems because they lacked proper understanding of the origins and quality of financial data. This highlighted the importance of strong data lineage systems. Now let us discuss data quality. Data quality refers to the accuracy, completeness, consistency, and reliability of data. High-quality data is essential for good decision-making and successful analytics. Poor data quality can lead to wrong business decisions, operational problems, and loss of customer trust. Common data quality problems include missing values, incorrect names or addresses, duplicate records, inconsistent formats, invalid entries. To improve data quality, organizations perform data cleansing, validation, and enrichment processes. Next, we will discuss ETL and ELT. ETL stands for extract, transform, and load. In ETL, data is first extracted from source systems, then transformed into the required format, finally loaded into a data warehouse or database. ETL is widely used in business intelligence and reporting systems. ELT stands for extract, load, and transform. In ELT, data is extracted and loaded first, then transformed within the target storage system. ELT is commonly used in modern cloud-based systems because it supports scalability and high-performance analytics. The choice between ETL and ELT depends on business requirements, infrastructure, and the volume of data. Now let us move to another important topic called data labeling. Data labeling is the process of assigning labels or tags to raw data so that machine learning models can learn from it. For example, an image of a dog may be labeled as dog, emails may be labeled as spam or not spam, customer reviews may be labeled as positive or negative. The quality of data labeling greatly affects the performance of machine learning models. There are three common types of data labeling. The first type is manual labeling. In this method, humans manually review and label the data. It provides high accuracy but can be time-consuming and expensive. The second type is automatic labeling. This method uses algorithms and predefined rules to assign labels automatically. It is faster and cheaper but may not always be perfectly accurate. The third type is semi-automatic labeling. This combines both human expertise and machine learning models. Some data is labeled manually, while AI systems help label the remaining data. Semi-automatic labeling is often considered the most practical approach because it balances speed, cost, and accuracy. Finally, it is important to understand that proper data ingestion, transformation, quality management, and labeling form the foundation of successful AI and analytic systems. Without quality data, even the most advanced AI models cannot perform effectively.